day, ladies and gentlemen. Welcome to lesson 1.4, domain and range. I will just do a special note here, ladies and gentlemen, to notice that we will be skipping lesson 1.3, and we'll come back to it in a couple lessons. I believe the order in the textbook isn't appropriate to what I see fit, so we'll just be switching a couple lessons. We will come back to 1.3 after we've learned a bit about domain and range. And the inverse function. All right, so we'll come back to that. To start off with today's lesson, though, on domain and range, we're going to take a look at some warm-ups. So we had some challenging questions for 16 and 17, and one was substitution, and one was determining some n values. So let's take a look. If you haven't got your homework out, pull it out, and we'll see where you went wrong, where you went right, and hopefully you went right versus wrong. If you weren't able to approach these questions, try starring them and then coming and seeing in class and talking to one of your classmates, or come to me and let's get these answers solved that you're having trouble with. Okay, here we go. 16a. You were given that f at x is this quadratic in standard form. You're also given that f at x equals 0. So just remember, guys, if f at x equals a standard form equation and equals 0, it's kind of like a substitution where you sub one into the other. It's kind of like two equations. So the left side, replace f at x with 0 because these two have to equal. So what we have here, ladies and gentlemen, is where we're solving quadratics. All right, and depending on how your teacher taught you to do this, to solve this quadratic, I'm going to try simple trinomial factoring, where my product is going to equal negative 15, okay, and that's where I'm getting this number from, and my sum is going to equal 2, which is your b, okay, and what two values, ladies and gentlemen, give us a sum of 2 and a product of negative 15. Well, the product's negative. You know one has to be positive, one has to be negative. So you either have negative 3 times 5 or 3 times negative 5. Or your other possibles are 1 times 15 or negative 1 times 15 or 1 times negative 15. Okay? Which one of those, ladies and gentlemen, gives you a sum of 2? And that is negative 3 and 5. Okay? And again, if you forget about factoring, you can go back and check that out. So to set these up, it's going to be x minus 3 and x plus 5. Then you take the square root of the first and then import your values that you found from the edge. That gives you the factoring, but don't forget it equals 0, so you got to solve it. And we use the zero product property, which means whatever the left side, how do we get the left side to equal the right side? Well, the left side equals 0, so how do we get the right side to equal 0? Notice that these are multipliers of each other, so you let each bracket equal 0. So maybe your teacher did something like this, and then you let x equals 3. X plus 5 equals 0, so x equals negative 5. So your two answers here for solving is that x equals negative 5 and x equals negative 3. Makes sense, ladies and gentlemen, that there's two solutions because when you have a parabola and you've got a horizontal value of f at x equals 0, those are your x-intercepts, okay? All right. Next question is that you got f at x equals negative 12. So negative 12 equals x squared plus 2x minus 15. Okay? And don't forget, let's bring all the constant terms over. So this becomes 0 equals x squared plus 2x. You take that negative 12, add it on the other side. So you're going to end up with negative 3. Now this is another case, guys. I'm going to run out of room, so I'll do it up here. Product equals negative 3. Your sum equals 2. What two values do you have, ladies and gentlemen? You got negative 1 and 3. That suits our case. So 0 equals x minus 1 times x plus 3. Now you may know, hey Ms. R, why are you always doing these scripted x's? It's so I don't get confused whenever you go with x multiply x. Okay, I always try to put a tail on my x. All right, now to solve, ladies and gentlemen, you can know that these are the opposite. So x equals 1 and x equals negative 3. All right, last question, ladies and gentlemen. F at x equals negative 16, so negative 16 equals x squared plus 2x minus 15. Bring the negative 16 over. So you're going to have x squared plus 2x plus 1. Now, if you didn't recognize that as a perfect square, you can make sure you do the product and the sum. So product equals 1, sum equals 2. What two values is 1 times 1? So if you didn't recognize that it's a perfect square, okay, it equals x plus 1 squared. So how do you get the right side to be 0? X has to be negative 1. So there's only one case. What does that mean, ladies and gentlemen? That on this equation, ladies and gentlemen, at x equals negative 1, that's where the vertex is. It hits. So there's only one solution there. Okay? All right. Just remember, for x-intercepts, ladies and gentlemen, you can have 0, 1, or 2. All right, 17. This is a tricky one, so we'll take a look at substitution in here, ladies and gentlemen. First one's not so bad. The second one gets a little crazy, but we can do it. All right, so the first one, f at a, so we're going to replace that wherever we see an x, we're going to put an a, so we've got 3a plus 1 equals g at a. So it's going to be 2 minus a, right? So you've substituted in here and here. Okay, so simplify that. That's 3a plus 1 equals 2 minus a. And you could have just written it like that. I just wanted to show, ladies and gentlemen, where the substitution was, i.e. we replaced x with a. Now all we have to do, it's a linear expression, and we just need to rearrange terms. So I already have 3a over here. I'm going to bring the negative 1 over, so you're going to have 4a on this side equals, on this side I have 2, I bring a negative 1 over, I have 1. To get a by itself, divide both sides by 4. So a equals 1 over 4. There's your answer to this one. All right, this is probably the hardest one, ladies and gentlemen, because we are having to deal with not just a linear, but we're going to get into quadratics here. Okay, so to substitute the left side, it's going to be 3 times a squared plus 1 equals 2. Subtract, take an x and replace it to 2a. Okay, so what does this look like? We have 3a squared plus a equals 2 minus 2a. Now we have a quadratic, ladies and gentlemen, so let's get all terms onto the positive a side. So positive a is this side, the left side. So we'll leave that term here. We'll bring the negative 2a over, becomes a plus 2a, and we'll collect like terms. So we'll have negative 1 for our constant on the left side. Now, ladies and gentlemen, remember that this is what we take a look at when we're factoring. And when a does not equal 1, this is called decomposition. Okay, and when we do decomposition, remember that the product equals a times c. And then we're going to split the middle term. So a times c, so that's going to be 3 times negative 1, which equals negative 3. And our sum is the same, which is 2. So what two numbers give you a product of negative 3 and a sum of 2? Well, that's going to be negative 1 times 3. But remember, because it's decomposition, we're going to split that middle term. So again, you may need to review this. Okay, so that middle term is going to be negative 1a and plus 3a. And I'm going to rewrite the rest just as it normally appears. Okay, then what we do after we've split the middle term, we're going to group factor by grouping. So what's common in the first two terms? We have an a, so we're left with 3a minus 1. Okay. What's common in the last two terms? Well, we can't take anything out except for 1. So that gives you 3a minus 1. You want to have the same thing in the brackets, guys. Okay, because that creates what we call a common binomial. So 3a minus 1 times a plus 1 equals 0. Then the last thing we have to do is to solve each bracket to use the zero product property. Okay, so 3a equals 1, a equals 1 over 3 if you divide through. and a equals -1. Now, ladies and gentlemen, some of you maybe have taken math first semester last year and now have it with me. So please don't be upset if some of this is a struggle to come back to remember. Just remember decomposition. Go back to your notes from last year. Or if you want, on my website, I keep my 2D notes as well. So you can just scroll through there and take a look. Okay, so that's open for you. All right, today's lesson. 1.4, domain and range. And again, this is an important topic that will be covered on your unit test and your final exam and throughout the course. Okay, for any relation, ladies and gentlemen, domain is a set of all possible values for x, which is the independent variable, whereas range is a set of all possible values for the dependent variable, y. All right, so think about it. The domain, let's change my colors to color code it here, guys. The domain deals with how far left or right you can go on a graph. Okay? Whereas when you're thinking about the range, how far up or down can you go on a graph? All right? Let's take a look at a mapping example here. Determine the, find the domain and range for the following. Okay. So taking a look at the first one, A, D, I'm just going to color code it. So D for domain, capital D, and we're going to do these funny brackets. As long as you make them swirly, it tells you that it's a set of values, okay? So domain equals or is a set of values, and you put them in numerical order. So the smallest one is -4, 0, 2, and 5. Because that's dealing with your x, right? Whereas when we do range, ladies and gentlemen, your range is a set of values in the in your y column and go in numerical order. So 0, 2, 3, 7. All right. Let's take a look at a list of data points, or you could think of this as a table of values, ladies and gentlemen. When we go to do our domain, domain is such that we have a set of numbers that, what's our smallest x value, ladies and gentlemen? -5, -3, 0, 2, and 3. Yeah, my swirly brackets sometimes aren't perfect either. Okay, and our range, ladies and gentlemen. Okay, when we take a look, our smallest value is -3. Okay, and then we go 0 and 1. And notice here, ladies and gentlemen, we got 2 3s, but we only have to include it once. So only list values once. Okay, so for example here, the 3 was twice. You didn't have to write it twice. All right, so when you're given a either data set, a mapping question, a table of values, or just specific dots on a graph, if you think about it, specific dots or points on the graph, then you just list the spots where they meet on the x and where they meet on the y. When you're given a relation or a function, ladies and gentlemen, where you've got a curved or a solid line, then we have something different. All right, and we're going to learn some new terminology. Domain is such that x belongs, that's a funny looking E, belongs to a set of real numbers. And in your textbook, you'll see R being bolded and capitalized. Okay, so the nomenclature is domain is such that x belongs to, that's what this means. It's Greek, it's a Greek letter, epsilon, I believe. Okay, belongs to, and R is the set of real numbers. All right. What does that mean, ladies and gentlemen? That as I extend my parabola, and I keep going and I keep going, it's getting further left and further right, each time. Okay? So there's no limit as I go left, and there's no limit as I go right, because it keeps going. Okay? So Let's just quickly review that. Domain is such that x belongs to a set of real numbers. Because remember, that's your left-right movement. And because the arrows represent a continuum, it keeps going, right? Oops, I forgot to, didn't mean to erase my arrows there. All right. Now, the range is a little different in this case. Okay? The range is your up-down movement. Okay? So first of all, range deals with y. So y belongs to a set of real numbers. Now we're going to put a bracket or a straight line that's called such that. Okay? Because we've got to have a restriction here. Looking at this graph, can we have any values above 3 for y? No, but we can have any values below y, so we're going to have to say y has to be less than or equal to 3. Okay, so this is basically stating restriction, so that every y values belong to a set of real numbers such that, and I'll put that down, such that y has to be less than or equal to 3. And basically the second part is your restriction. All right. Let's try our last one, a circle. Okay, so if you're wondering what the formula for this would be, it'd be x squared plus y squared equals r squared, and r is 5, so that would be equal to 25 if you're wondering what the equation is. Okay, so domain. How far left and how far right can I go? Well, because it's a relation, you can tell me that x belongs to a set of real numbers such that, what are my limits? So how far left can I go on my x? -5, and how far right can I go? 5. So basically, put my x in the middle, and I say, hey, x has to be greater than or equal to -5, but it has to be less than or equal to 5. All right. Now I deal with my range. How far down can I go? But maximum I go is -5. How far up can I go? Maximum is 5. So range is such that y belongs to a set of, range is such that y belongs, y, see, this is where I hate the video part, sorry. Range is a set of, y belongs to a set of real numbers such that -5 is my minimum value, has to be less than or equal to y, which has to be less than or equal to 5. All right. Here's our summary, ladies and gentlemen. So, when you're given a list of points or table of values or mapping, so you can put T of V here, mapping as well, all you're going to do is list all possible values or outcomes in numerical order. And I would suggest you put in here no repeats. You don't have to repeat it because it's already been counted for. All right. So if you're given a graph with a solid line, that means a relation. Okay. Then you're going to start with either x belongs to a set of real numbers or y belongs to a set of real numbers. And then you're going to state any restrictions. So that's my funny symbol for and. Okay. All right. Cool. Now let's deal with domain and range from an equation. All right. Taking a look at example 2, find the domain and range from an equation. Well, all I want you to do, folks, is visualize. If you're given an equation, think of the graph. Just like when we were testing for the vertical line test, same thing. Okay. Well, first of all, what do we know about A? Okay, we know that it's a linear relation. Okay. So it's linear because there's no exponents. Okay. And if there's no exponents and there's no restrictions, i.e. there's no vertical or horizontal line, you can tell there's a slope to it, guys. So what does that tell us? It tells us that domain is that x belongs to a set of real numbers. And I'm going to keep the colors the same this time. And the range is y belongs to a set of real numbers also. If you wanted to quickly visually draw that graph, guys, just remember your y-intercept is at what? -7. And as you go up 2, you go over 1, up 2, over 1, up 2. So your graph looks like this. So if you want to visualize as you go left or right, there's no restrictions. Likewise, as you go up or down, there's no restrictions. Okay? All right. Taking a look at our B, we notice that this is a parabola and it's vertex form. Okay? So it's a quadratic. Okay? What do we know about this quadratic? First of all, we know that the vertex is what value, guys? The vertex is 2 and 5. And we know the direction of opening by looking at A. So A equals -3, therefore it opens down. Okay? So if you wanted to draw that, ladies and gentlemen, quickly, 2 and 5 would be over here. Sorry, I'll fix that graph a bit. Just do it in here so I've got more room. Okay. So 2 and then 5 would be here, and we know it opens down, right? This is at 5, right? That's at 2. So we know it opens down. Okay? So what we know, ladies and gentlemen, from this is that our domain is where x belongs to a set of real numbers. But our range, we have a limit, ladies and gentlemen, because we're stuck as we try to go up. So what does that tell us? Y belongs to a set of real numbers such that, what's the maximum y can be? 5. So y has to be greater than or equal to 5. All right. And you might be going, Mrs. R, look at C. What is that? Okay, this is what we call a new, function, and it's called the square root function, or square root relation. Okay. And I don't expect you to know too much about this right now, but I want you to remember back in grade 10 when we had square roots and we had negative values. Do you remember that we couldn't solve that? So you can't have a negative under the square root. Because you wouldn't get an answer, right? Okay, your error in your calculator if you tried doing that. So just do a quick thing. Take a calculator out, go, I don't know, square root of -20. It's going to give you error. Square root of your favorite number and make it negative, and you'll get an error. Okay? So what do we need to remember, folks, is that in function notation, another way to write the square root if we use our exponent laws is that it's raised to the 1/2 if you're not sure. Okay, so the only way to not have a negative in the square root is to say, hey, whatever's in the square root, i.e., 2x minus 4, has to be greater than or equal to 0. This is what we call an inequality, and we're going to solve for the inequality right now. So 2x, and we're going to take the -4, bring it over, becomes +4. And then to solve for x, divide both sides by 2. So x equals, sorry, my fault. X has to be greater than or equal to 2. Okay? So what does that tell us, ladies and gentlemen? One thing is that the domain is that x belongs to a set of real numbers such that we just solved that x has to be greater than or equal to 2. And the other part to think about it is the range is where y belongs to set a real number such that y has to be greater than or equal to 0. That's just because of the property of a square root, right? You can't have it being negative. Okay, so that's where that one comes. Okay? Alrighty. Moving on, and here's a hard one, ladies and gentlemen. So get your ears on. If you haven't got them on, let's pay full attention here and make sure you do this one with me. Okay? These were the hard questions from grade 10. Suppose you have 40 meters of fencing to enclose a rectangular pen. So what does that 40 meters represent in terms of measurement? That gives you your perimeter. So perimeter equals 40 meters. Express the area of a pen as a function of its width. What does that mean? I'm going to go area in terms of its width. Okay? And then it says to find the domain and range. All right, so let's just quickly draw a pen. Okay? And don't fill too many things in right now. We do want to use W for width. But in order to solve and to find, to solve for the area, we've got to keep one variable. So we're going to replace, instead of using length and width, we're going to express length as a function of width. How do we do that? We're going to use our perimeter formula. What do we know? We know that P equals 2 lengths plus 2 widths. Everybody good with that? Let's sub in our 40. So 40 equals 2 lengths plus 2 widths. Now let's get length by itself. So it's going to be 40 minus 2 widths equals 2 length. Everybody good with that? And to get length by itself, divide by 2. So we should end up with 20 minus W equals L. So instead of writing down L on our diagram, we're going to write down 20 minus W. Everybody good with that? All right, cool. All right, so now that we've got our diagram, we can answer question A. Question A is express the area of the pen as a function of its width. So normally you would go area equals length times width, but we're going to go area as a function of width equals, what's my length? 20 minus W times my width, which is W. That is a fine answer if you want to leave it like that. Or, ladies and gentlemen, you could use distributive law and have 20W minus W squared, but I would expect you to put your highest order first. Okay, so I would accept either answer like that. Okay, next one, find the domain and range of this function. Okay, well what we have to do is remember to maximize the area. We want to create what we call a square, right? Okay, so to do B, domain and range, okay, we're looking at the maximum area. And maximum area, hopefully, if you remember by optimization, we want a square, right? So we want a square. Each side has to be the same length. So to find your width, that's going to be the perimeter divided by 4. Okay? So width equals, what's our perimeter, guys? We said it was 40. So 40 divided by 4 equals 10 meters. So what does that mean? That means that when our width is 10, we can find the maximum area. So we already know A at X equals, I'm going to just rewrite our statement here. All right, now we're going to do A at 10. So we're going to sub in X being the value of my width. I apologize. Shouldn't have X, I should have width there. Again, please use your eraser. Sorry about that. So we're going to sub in our 10 for our width. So that's going to be negative 10 squared plus 20 times 10. Subbing that in, you're going to notice that you end up with negative 100 plus 200. So the maximum area equals 100. Okay, what does that tell us, ladies and gentlemen? I'm just going to make some more room here. Sorry. Give me 1 second. Okay, what does that tell us, guys? If we quickly wanted to graph width versus height, so if this is my width and this is my, sorry, width versus area, okay, the maximum area we can reach is going to be at 100, okay, and then it's going to come down, go up and come back down, okay. If we know, ladies and gentlemen, that it took us a width of 10 to get to our maximum height of 100, so our vertex there is 10 and 100, what would be our limits to our parabola in this case? The minimum value of width would be what? 0, and your maximum has got to be symmetrical, so it's got to be 20. Okay? So again, this is very restrictive when we deal with measurements. Okay? So taking a look, now we can answer B. Domain is where the width belongs to a set of real numbers such that, what's the values that width has to be? Has to be greater than 0 but less than 20. But the width of 0 can't exist because then your area wouldn't work. Okay? Whereas when we take a look at the range, our up-down movement, okay, so you could either write Y or A at W here. You're going to see in your textbook varying answers. So A at W belongs to a set of real numbers such that can't be 0, but it can be what? It can either be up to or equal to what? 100. Because it can fit anywhere along this here. All right. That's a tricky one, ladies and gentlemen. Those are like your high-end inquiry questions. Please give it a try. Don't give up on them, and come see me for some help. Here's your homework, guys. Page 35, numbers 1 to 3, 9, 10, 13, and give 16 a try. Have a fabulous day. Enjoy.